Good morning, children. Hope you all are doing good at home. With regard to physics, we had already started studying this chapter, electricity. I have already sent you one PPT and one video on the various concepts of this chapter. Hope you all have gone through it and understood as well. In today's session, what I thought was I will pick few concepts, important topics which we have already discussed in the previous two sessions and explain it to you on the board so that it will be more clearer to you and you will understand it better. Clear, children? So let us begin. Electricity. Electricity is a wide branch of physics which is divided into two branches mainly, that is static electricity and current electricity. I've already explained you what are these in the previous session, but still to revise, to glance once with, static means the word itself tell you that is rest. So if you study about the charges, electricity is nothing but the study of charges. You all have studied about the charges in your lower class. What are charges? How many types of charges are there? Everything. So this electricity chapter is completely about the study of charges. But there are two branches, as I said, static electricity, current electricity. Static means something which is at rest. So here we study about the charges at rest, and current means which is flowing or which is in motion. So current electricity means we study about the flow of charges. To explain you what is static electricity, let us consider an example. You all have performed one small experiment no, in your lower classes. Like when you take a comb, rub it to your hair and hold it on the pieces of paper, the pieces of papers, those get attracted to the comb. Yes, no? Why? Because the charges is present there. The charge is present there. Hence, that is the best example for the static electricity. But in this chapter, mainly we will study about the flow of charges. How do the charge flow? What does it constitute? Everything. So that is current electricity. So in this chapter, electricity, we are mainly studying about the current electricity. In your lower classes, you all have studied that protons and neutrons, which constitutes the nucleus. Protons and neutrons together make the nucleus, is in the center, and all the electrons are revolving around the nucleus. See, these circles what you can see are electrons. I said you previously, children, electrons means now onwards you should not write in whole world. How do you represent the electron? Means e to the power minus e by electron. So its first letter e, y to the power minus sign. You all know that electron is negatively charged particle. Hence, you represent E minus. So, this protons and neutrons mimics the nucleus, and all the electrons are revolving around the nucleus in the outer shells or the outer orbits. So, now protons are positively charged and its charge is plus 1.6 into 10 to the power minus 19 Coulomb. What is Coulomb? I said you already, the unit of charge is Coulomb. And electron is the negatively charged particle and its charge is minus 1.6 into 10 to the power minus 19 Coulomb. Keep this in mind, children. Proton and electron both have same value, that is 1.6 into 10 power minus 19, 1.6 into 10 power minus 19. Proton. So we learned that unit of charge is measured in terms of coulombs. 1 coulomb consists of how many charge in it? To find out that, how we do is 1 coulomb of charge is 1 by 1.6 into 10 to the power minus 19 electrons. So 1 coulomb of charge, if we tell, it consists of 1 by 1.6 into 10 to the power minus 19 electrons. So when you simplify this, 1 divided by 1.6, when you do, you get 0.625 into 10 to the power plus 19 coulomb. Why plus 19 coulomb? Because when you simplify, this 10 to the power minus 19 will go to the numerator. When it goes to the numerator, you have learnt in the law of exponents in mathematics, no? 10 power 9 minus 19 becomes 10 to the power plus 19. So 0.625 into 10 to the power plus 19 you get. In the previous video, children, while solving few numericals, I said you how to shift these decimal points. When you shift these decimal points, how does this power value vary? So based on that, see now, I got 0.625, right? So this I will write it as 6.2. I am leaving this 5. Okay, you can neglect it. So when I shift this this decimal point after 6, I get 6.2 into 10 to the power plus 19 is there. When you are shifting the decimal point in the forward direction, what will happen? As I said, if you remember, you will subtract 1. You will subtract 1. If you are shifting one decimal point in the forward direction, you should subtract 1 from its power. If you are shifting 2 decimal points in the forward direction, you should subtract minus 2. 3 decimal points, minus 3. Similarly, if you are shifting the decimal point in the backward direction, you will go on adding so many plus 1, plus 2, plus 3 like that. I have shown you clearly in the previous videos. Similarly, here also, when I shift 0 point after 6, it becomes 6.2 into 10 to the power 18 electrons. You have answered in the worksheet, no? 1 coulomb of charge consists of how many electrons? It is 6.2 into 10 to the power 18 electrons. How we got so? By doing this simplification. 1 by 1.6 gives you 6.2 into 10 to the power 18 electrons. So when these charges are in motion, when these charges are flowing, it constitutes what is called electric current. So how do you define electric current? It is very simple. It is just the flow of charges. Electric current is the flow of charge. How does this current come? For the current, see, current comes from this electric potential difference or voltage. Current comes from electric potential difference or voltage. You all have heard about the voltage. Yes, no? In general talks, you tell voltage drop, no voltage, so no charge, like something you will tell, no, like that only. This term voltage. What is this voltage? What are we talking about when we say there is voltage drop or no voltage or high voltage? When there is thunder and lightning due to high voltage, the TV got damaged, the fridge got damaged, like that we talk, no, generally. What is this voltage? So children, we studied that the flow of charges constitutes the current, electric current. How do you measure this electric current? So as we learned that we are measuring the charges in terms of Coulomb. The current, that is electricity, is measured in terms of ampere. That is, unit of current is ampere, and it is represented by capital letter A. So whenever you are solving the numericals or you are writing the value of current, 2 amperes, 3 amperes, 10 amperes, like that, we mention it in terms of amperes or simply the letter A. Capital letter A also tells that it is ampere, that is the unit of current. We measure the current also in terms of milliamperes and microampere. Milli means you all know, no? It is 10 to the power minus 3 is milliampere and 10 to the power minus 6 is microampere. How do you measure the current? We need some instrument, no, to check how much current is flowing in the circuit. That instrument is called the ammeter. We have discussed already all these things, children. I am just revising it. Ammeter is the instrument which is used to measure the current flowing in the circuit. And it is always connected in series in a circuit. Keep in mind, children, ammeter is a device which is used to measure the current and it is always connected in series. In the worksheets, I saw many of you writing it is connected in both, it can be connected both in series and parallel. No, you are wrong. Ammeter is an instrument which is used to measure the current and it is always connected in series in any electrical circuit.